Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 14th, 2025, just yesterday. The hook is simple. This paper formalizes vibe coding as a constrained Markov decision process and delivers the first full taxonomy, showing that success depends more on context engineering, development environments, and human-agent collaboration than on raw agent power. The paper is titled, A Survey of Vibe Coding with Large Language Models, and the implications for developer workflows are significant. Beyond theory, the survey maps 4 infrastructure pillars and reports wide benchmark variance on SWE bench variance from 12.5% and 19.0% to 27.3% and up to 53% with advanced interfaces. Also, the authors shared a GitHub repo that's essentially an awesome list for vibe coding. You'll find a well-structured README with their taxonomy, summaries, and curated links across LLMs for code, agent capabilities, planning, memory, tool use environments, and feedback mechanisms. It's a comprehensive reference hub rather than runnable code. So Figure 1 maps the whole vibe coding landscape as a taxonomy, which means a structured roadmap of the parts that must work together. The chart organizes 4 pillars that drive outcomes, not just model power. The top block covers large language model foundations. The next block details coding agent capabilities. Below that sits the development environment layer, and the bottom band summarizes feedback mechanisms that keep agents aligned and reliable. Alright, Figure 2 shows the core interaction loop that makes vibe coding work, emphasizing results over line-by-line code reading. The diagram frames a triad: the developer, the project context, and the coding agent, which communicate through instruction, feedback, coding, and review. The top band represents project context, meaning the codebase, data, domain knowledge, and the execution environment that constrain actions. The left panel depicts the developer's role in ideation, evaluation, and discussion. The right panel highlights the agent's tools, memory, and task execution, while the center loop conveys continuous instruction and feedback. So, Figure 2 showed the triad loop. Table 1 now catalogs the datasets that power and evaluate vibe coding systems. This table maps each dataset to scale, languages, collection method, and purpose, which helps practitioners pick data that matches agent goals. The left column lists names like SWE bench variance, leet code dataset, and open code reasoning. The right columns describe test availability and project level tasks, so teams can align training with evaluation. So, Figure 8 compares vibe coding models against classic software methods along 2 axes, constraints on the vertical and development speed on the horizontal. The blue dots mark UAM, ICCM, PDM, and TDM, while red dots show waterfall, agile, and rapid application development. The chart suggests context-enhanced practices push workflows towards safer and faster regions. Context-enhanced means adding retrieval and rule constraints that enrich the agent's working context. Wrapping up, 2 takeaways stand out. Vibe coding gets a formal backbone as a constrained Markov decision process, and real success hinges on context engineering, robust environments, and human-agent collaboration more than raw model power. The implication is clear: build integrated tooling, safety, and oversight to make outcome-driven development reliable. That is it for the AI Research Roundup. I'm Alex. Thanks for listening.